Now, we need to find two things that multiply to equal x squared minus 9. I think what they're looking for, since p of x is x squared minus 9, can you see that you could have factored that? X plus 3, x minus 3. So I think what the textbook was hoping you'd say is, let's make f of x equal to x plus 3 and g of x equal to x minus 3. But is there a way to cheat in the multiplication one as well? What happens if I made f of x x squared minus 9? Exactly the same as what I started with. What should g of x be? 1. Not wrong. Full marks. Given q of x equals x plus 1. Do you agree that you could write this as x plus 1 over 1? And then f of x could be x plus 1, and g of x could be 1. It's kind of cheating as well. But we have to be a little bit careful, because sometimes what students will do is they'll make this equation, x plus 1, x plus 2, x plus 2. Doesn't that simplify to the same thing? But what's the difference between this one and this one? The bottom one has a non-permissible value. The top one doesn't. So there would be a small error if you chose x plus 1, x plus 2, and x plus 2 as your functions. You would get a small error because you've introduced a non-permissible value. You have to be careful with dividing. So having x plus 2's there could be problematic. If you put a number there, you're perfectly fine. No non-permissible value. But why make it overly difficult if you could just make the bottom function a 1? And there's your questions for practice.